Let's play some more with polymorphic data types. In this program, we've got a type container, and it's got one variant bin. Right now, the argument to bin has to be an int, so we can make a bin of 1, but we cannot make a bin of true. If we were to place this int with alpha, what we get now is an error, because this type is probably a mistake. The container is not a polymorphic type, and yet it has this wildcard A on the inside of it. If this sort of thing was allowed, then the first time that we used bin, we would set the type what has to go inside of it. So bin1 would be okay, and then if we had later on tried to do bin true, that would be an error. This kind of behavior, filling in a wildcard with something at the first use, can be a little bit surprising, so that's why Shplait makes it an error, and the other ML languages make it an error as well. If we really want a polymorphic container, then we could declare that type variable up at the top. And in keeping with the convention that we've been using for lists and other containers, let's call this container of, and now we can make different kinds of bins on the right. It all works because container of alpha is a polymorphic type. Now, this example points out a distinction, which is pretty rare to run into, but it's worth knowing about. There's a difference between type variables like alpha, which are bound with a big lambda or bound by a data type, and type variables that just appear, like this unguarded one. And the difference shows up when you're writing code that does use a type variable, but that doesn't appear inside of a definition or a let binding. So let's go on the right here and write down the identity function. And this identity has a type that we haven't seen before in these lectures, underscore A arrow underscore A. That's different than the normal identity type. And that's because the second identity function didn't appear in a definition, so it's not able to be generalized to have a for all type. Anytime you see something like underscore alpha, that's a wildcard that can be filled in later, but it can only be filled in once. Internally, this type does not have a for all on the outside of it. The other one up above, that does have a for all, so that identity function can be applied to any arguments. Let's illustrate the difference with an example. First, with this ident on the left, we can call that with two different types, ident1, ident true. That's all fine. The other kind of function with that underscore A or weak alpha, we can get that by using our fun directly. Instead of making a def, let's just apply that to another function, which expects a function and then creates a pair with two calls to f, f1 and f true. This one is a type error, int versus Boolean, because the first call to that f fills in the wildcard with type int. So that means the second call to f gets ruled out. And again, all this trouble is because our function there has a weak alpha type, underscore A, because Shplait won't infer for all types in arbitrary positions, only for definitions.